our final lab in physics, we were able to choose our own adventure. I chose to explain the forces involved in the motion of a ball in free fall motion. The steps I took were I took the video of the soccer ball, I analyzed the motion of the soccer ball in Tracker, I modeled the motion using VPython incorporating drag forces, and at the end I'll summarize what I learned from this lab. Physics concepts we'll use are Newton's second law to predict the future velocity, the weight force, which is one of the forces acting on the ball, and the drag force, which is the other force acting on the ball in motion. Here's the video of the ball in motion. I analyzed the video in Tracker and placed the origin of my axes at the center of the ball, with the negative x-axis pointing to the left and the positive y-axis pointing upwards. I set my calibration stick equal to 0.2062 meters, which is the diameter of a soccer ball which I measured beforehand. And here is the video of the motion. I chose to set my axes according to when the ball was at rest, but as you can see, the kick takes place between frames 2 and 3. So using these data points, frames 2 and 3, we can calculate the initial velocity of the ball after the kick. And here we do just that. We calculate the initial velocity vector by splitting up its x and y components, and I got these data points according to the Tracker table I just showed you. And as we remember, velocity is equal to r final minus r initial all over delta t. And as you can see, I did that for each component of the velocity vector and got these values. Now that we have our data, we can now model the ball's motion using VPython. Here I set the ball's mass equal to 0.35439 kilograms. Here I set the initial position of the ball as this vector, which is taken from the first line of our Tracker data. And here I set the initial velocity vector of the ball, which I just showed how to calculate. Here we set our time equal to 0. Then we make this a relatively small time interval. So for our while loop, here we set the proportionality constant g for the magnitude of the weight force, which is 9.8 meters per second, and the j hat unit vector for the weight force, which usually points upwards in this case. And here I found the proportionality constant for our drag force after repeated runs of my code, so that way my x value matches very closely to what was printed out after the statement. And I got a value of 0.006601. And here we have our calculation loop. Here I set the total time expired as the total time that expired between the beginning and end frame of the video that I chose. Here I set the weight force formula as code, which is negative mg in the downwards direction. Here I find the unit vector of the ball's velocity, which is the vector divided by the magnitude of that vector. Here I find I put the formula for the drag force, which in this case I put as negative b times the velocity squared times the ball height unit vector. The reason it's negative b is because drag force is usually opposite to the ball's velocity. So this will take care of that. And F net is equal to the weight force plus the drag force. Here I find the ball's future velocity using Newton's second law. Here I predict the new position, and here we advance our clock. And here I set the arrow scale as 0.5, so that way our arrows are proportional to the forces acting on the ball. Now we run our code. Here our print statement prints out the total time expired and the x and y components of the final position vector. As you can see, our x component is negative 9.052, which matches very closely to that found in our final Tracker spreadsheet, which is negative 9.052. Although my code predicts the x position of the ball very closely, it does not predict the y position of the ball very well. As you can see, it prints out negative 2.045, while the final y position was just negative 0.638. And I hypothesize that it could be because it was raining when I took this video, so my code does not account for the force acting like a drag force caused by the rain. Also, the ball could have been kicked in an angle which would cause it to move in the z direction, which my video does not pick up. However, I can change my proportionality constant to make my y value match more closely to the Tracker value given. but it will overpredict the X component position of my ball. So overall, my code overpredicts the position of the ball. Thank you for watching my Physics Lab 5 presentation.